Hello and welcome to Physics with Amol sir. So this video is for class 10 and today we are going to continue with the chapter of human eye and the colorful world. Previously we spoke about the formation of rainbow. Today we will see the concept of atmospheric refraction. Okay, so let's begin. So what is atmospheric refraction? Our atmosphere, it consists of large number of gases along with many ionic particles. Then there are smoke particles. Okay, all these things they make up our atmosphere. Along with this, there is lot of smoke. There is lot of dust particles that are also present in the atmosphere. So, because of all these things, whenever light passes through the atmosphere, it undergoes refraction. Okay, so when light is coming from the sun, when it passes through space, okay, there is a vacuum in space. So from space, when it enters our atmosphere, it undergoes refraction. And this is basically the concept of atmospheric refraction. Along with this, even when light travels from one point to another on the earth itself, that is in the atmosphere, even then there is a refraction, because the atmosphere is not constant throughout. At some parts it is more dense, at some parts it is less dense. Okay, so that causes refraction there also. So these things, they cause the concept of atmospheric refraction, and because of this there are some phenomena that we observe. So let us see those one by one. So one of the effects that we see due to atmospheric refraction is the twinkling of stars. I'm sure you know that when we look in the night sky, we are able to see stars as well as planets. Stars, when we look at stars, they look like they are twinkling. Twinkling means the brightness and means the brightness keeps on changing. They look more bright than less bright, right? And when we see that, we know we are looking at a star. But when we see a planet, that planet does not twinkle. The light from a planet, it looks very much uniform. Okay, and this twinkling of the stars, it happens due to atmospheric refraction. Let us see how. Now our stars, whichever stars that we see in our night sky, they are very very far away. They are light years away from our earth. So we can consider these stars to be point sources of light. Point sources means what? The light that is coming from these stars, we can consider it as a single ray of light. So let us say this is our earth, this is where we are present, and on our earth this is the layer of atmosphere. Okay, very far away there is a star, and from earth we are looking at this star. As the star is very far away, we will consider it a point source. So the light that is coming from the star will come like this. Okay, single ray of light. When this ray of light enters our atmosphere, as we said, our atmosphere consists of large amount of things, gases and molecules. Okay, then ions and dust particles. All these things, they will cause refraction. Okay, they will result in a refraction of this ray of light, and this ray of light will get refracted. But what happens is, these gases, they are not in a state of rest. They are constantly moving. There are pressure changes that are taking place on our earth continuously. Because of this, our atmosphere is in a constant state of flux. Okay, it is in a constant state of motion. This causes change in the refractive index of our atmosphere. As the refractive index changes, so the angle of refraction will also change. So what will happen is, if you are located over here, what will happen is, sometimes all the light from the star is coming here. Then because of refraction, sometimes the light will go here or sometimes here. So what will happen is, the amount of light that we are seeing, it will keep on changing. Sometimes when more light is coming, the star will look bright. When less light is coming, the star will look dim. And this causes the twinkling of the stars. Getting the idea? So because they are very far away, and because the atmospheric refraction, the star appears as if it is changing. This entire answer you will find in the notes that I have already given to you. Okay, the question is, explain the phenomena of twinkling of stars. Now the next question you will ask is, if the stars are twinkling, then why planets do not twinkle? Okay, so here is the reason. First we have to understand stars are very far away, so they are point sources. Now planets, they are comparatively much closer to us as compared to the stars. Okay, so if there is a planet, which is the planet just next to the Earth, I am sure you remember, that is the planet Mars. So Mars, it is at a distance of around 10 crore kilometers from the Earth. As compared to the stars, it is much closer. Now of course 10 crore kilometers is also very far away, but as compared to the other stars, we can say it is very much closer. And because our planet, that planet Mars is closer, it is going to look much bigger as compared to the star. So there are many rays of light that are coming from the planet. Okay, so as compared to the star, from the star only one ray of light we could imagine. It is a point source. But a planet is not a point source. So there is a large amount of light, that is many rays of light are coming from the planet. So even if they undergo atmospheric refraction, what will happen is the total amount of light will remain approximately constant. Okay, because even if let us say out of these 100 rays, 90 rays are being focused on the observer. Even if the refraction changes, again the same amount of rays will be there, even if they tend to change like this. So the light that is coming from the planet seems to be constant, and therefore planets do not twinkle. Reason is they are much closer to the Earth, and therefore they are not point sources. Large amount of light is coming from them. Okay, so this can be an activity done by you. Now if the atmosphere is not cloudy, tonight you can go and see the night sky. Okay, if it is clear, you can actually distinguish between planets and stars. If it is twinkling, that means it is a star. If it is not twinkling, it is a planet. In fact, nowadays you are actually able to see three planets very clearly. You are able to see Jupiter, Saturn and Mars. So let us say somewhere around 7 to 8 o'clock, you can actually see the planet Jupiter and Saturn. Okay, and maybe around 9 o'clock or 10 o'clock, you will be able to see the planet Mars. You can download an app on your mobile, Star Chart, that will actually help you to identify these planets. Okay, if it is a clear sky, I will urge you should go and see it. And of course, if you are waking up at 4 o'clock in the morning, you can actually see the planet Venus as well. But during night time, very clearly you are able to see these three planets. Okay, Jupiter, Saturn and Mars. Mars will look a little reddish in color. Jupiter will look very much bright. Okay, it will look much larger as compared to Mars and Saturn also. Saturn will look very much smaller. But you can actually identify all these three planets in the sky. So I urge you to see these planets tonight. Another phenomena that occurs due to this atmospheric refraction is the phenomena of advanced sunrise and delayed sunset. So what is the meaning? We are actually able to see the sunrise 2 minutes before it is actually crossing the horizon, and sunset we are actually seeing 2 minutes later. Okay, maybe it is sounding too much confusing, so let us see. Okay, imagine this is our Earth. Okay, so if we are at a point over here, when should you see the sunrise taking place? Sunrise should occur when, if I draw a tangent to where I am over here, when the sun crosses this tangent is nothing but the horizon, right? So when the sun crosses the tangent, only then we should be able to see the sunrise, correct? When should we see the sunset? When the sun has gone below this tangent, that is below the horizon. That is when we should be able to see the sunset. But see, because of refraction, something very wonderful happens. Imagine the sun is over here. Okay, it has actually not touched the horizon. But what is there around our Earth? Around our Earth, we have our atmosphere. Okay, so light from the sun, it reaches the atmosphere like this. And because of the atmosphere, it undergoes refraction. And the light refracts in this manner. So what happens is, even before the sun has actually crossed the horizon, over here, we are able to see the sunrise taking place. And the opposite thing happens during the sunset. During sunset, what happens? The sun reaches the horizon, we are able to see. The sun goes below the horizon over here. But still, due to the atmospheric refraction taking place, we are still able to see the sun. So what happens is, 2 minutes before the sunrise and 2 minutes after the sunset, we are still able to see the sun. Okay, so this is the phenomena of advanced sunrise and delayed sunset. Okay, so this is also one of the questions that is asked. So I hope all these concepts were understood. In exam, these questions are asked. Okay, that is, why do stars twinkle? Why planets do not twinkle? Then what is the phenomena of advanced sunrise and delayed sunset? So make sure you are writing all these questions from the notes that I have given and you are understanding this particular concept. Okay, in the next class we will talk about the concept of scattering of light and we are going to see some numericals based on the eye defects. With that, this particular chapter will be over. So make sure you have understood these concepts. If there are still any doubts, ensure that you are asking me. Okay, thank you.